Hello everyone, welcome to Tech Tools YouTube channel. Today in this video, I am going to make some open loop systems using MATLAB Simulink. So let's start today's video. So to build a open loop system, first we need a transfer function block. So double click on screen and write transfer function. So this one is our transfer function block. Then we need a step input. Double click and write step. So it is our step input. Then to find the produced waveform, we need a scope. So double click and write scope. So this one is our scope. Then just connect the terminals. Let's increase the size of the block diagrams. So this one is our step input. This one is our transfer function block, and this one is our scope. Let's write the names. So this one is step input, this one is transfer function, and this one is our scope. So now let's run the simulation and see the produced waveform. So this one is our transfer function waveform. If we want to see the input also, then we have to increase the number of terminals in the scope. So how we can do that? Double click on scope, then go to the settings side, then number of inputs you have to select it 2, then apply. So you can see there are 2 terminals. So let's join this terminal to the input signal. Now you run. So the blue one is our input and the yellow one is our transfer function. So let's do one thing. Go to the view, select legend. Now you can see that the yellow one is our transfer function and the blue one is our step input. If we want to see it more clearly, we need another block. That one is dashboard scope. So double click on screen and write dashboard. So here is our dashboard scope. Let's increase the size of dashboard scope. Now double click on dashboard scope. Then select the input wire. You can see this one is step input as it is directly connected to the scope. So select it, then go to this one is output wire, then go to the output wire, select it and tick, then apply, then press on run button. Here you can see the blue one is our step input and the red one is our transfer function. It is also mentioned here that the red one is our transfer function and the blue one is our step input. Now in this video we are going to see some different transfer function and their graphs. So let's change the values of the transfer function. Double click on transfer function block. So at first we will see if the number of numerator coefficient and the number of denominator coefficient is same. So let's reduce the denominator coefficient. Now you can see here is one numerator coefficient and one denominator coefficient. Now apply it and press OK. So let's see the graph for 1/1 transfer function. Yeah, so for 1/1 transfer function, the transfer function graph is like step input. So let's change the values. If the denominator coefficient is 2, So you can see number of numerator coefficient is 1 and denominator coefficient is 2. Apply, okay, and run. This one is our input graph and this one is our transfer function. If the numerator coefficient is 2 and denominator coefficient is 2, now let's check for if the number of numerator coefficient and number of denominator coefficient is same. Double click on transfer function block and increase the number of numerator coefficient into 2. So you can see now the number of numerator coefficient is 2 and denominator coefficient is also 2. Apply, press OK, then run. Yeah, for numerator and denominator coefficient, if the numerator and denominator coefficient is same, then the graph will be like this. It will start from this side. It will not start from here. You can see in the previous ones, the transfer function graph was started from this point. But if the numerator and denominator coefficient is same, then the graph will start from this side. This part will remain constant. So let's see some other examples. Double click on transfer function block and increase the number of denominator coefficient in 3. So now the number of denominator coefficient is 2 and denominator coefficient is 3. Press apply, OK, and run. Now you can see this one is step input and this one is our transfer function graph. Here you can see that this starts from here because the denominator coefficient is greater than numerator coefficient. In all the cases where the numerator coefficient is less than denominator coefficient, the graph will start from here. Now we will see for same number of numerator and denominator coefficient, that is 3. Double click on transfer function. Let's change the numerator coefficient value to 3. So number of numerator coefficient, so number of numerator coefficient is 3 and denominator coefficient is also 3. As we see earlier, we know from where the graph will start from. Just apply, OK, and before running the program, we know, so before running the simulation, we know that the graph will start from this point. So let's see what happens. Run. Yeah, this exactly starts from this point. As we assumed earlier, our assumption is correct. So let's check for numerator coefficient is 3 and denominator coefficient is 4. Go to transfer function and change the denominator coefficient to 4. So number of numerator coefficient is 3 and denominator coefficient is 4. Just apply, OK, and run. Yeah, in this case it starts from here. As we know earlier, if the number of denominator coefficient is greater, then the graph will start from here. One another point, if you can't see the transfer function you have selected, so just increase the size of transfer function block, then you will be able to see the transfer function you have selected. So now it's visible. Now change the number of numerator coefficient and denominator coefficient to 4. Now let's see if the numerator and denominator coefficient are same, that is 4. Double click on here and just increase the number of numerator coefficient to 4. So here you can see number of numerator coefficient is 4 and denominator coefficient is also 4. apply. Okay, we know the graph will start from here. Now run. Yeah, it exactly start from this point. So now we are pretty much sure that if the number of numerator and denominator coefficient are same, then the graph will start from this point. And if the numerator coefficient is less than denominator coefficient, the graph will start from this point, from 1. So let's check for denominator coefficient 5 and numerator coefficient 4. Apply. Okay. So we know now the graph will start from point 1. Let's check it, run. Here you can see it starts from here as we assumed earlier. So the most important key point is if the numerator coefficient is greater than denominator coefficient, then that will be a improper transfer function. So for that case, we don't have any graph. So the graph is only valid for proper transfer function. So what's a proper transfer function? So what's a proper transfer function? For a proper transfer function, number of numerator and number of denominator should be same, or number of numerator should be less than number of denominator. In case of number of numerator is greater than number of denominator, it will be an improper transfer function. So for that case, the graph will not be valid. So let's check it. If we change the number of numerator coefficient is 6 and number of denominator coefficient to 5. So you can see number of numerator coefficient is greater than number of denominator coefficient. So for this case, the graph will not be valid. Let's check it, apply. Yeah, you can see it's showing error. So it will not valid. So I hope you guys understand what I am explaining to you. So I hope you guys understand what I am explaining. So that's it for today's video. In the next video, I will show you what is a closed loop transfer function and how the graph will form. So thanks for joining me.